Hey everybody. So this paper is as hot off the presses as it gets, and this is an intriguing paper that potentially has a lot of breakthroughs as long as everything with it holds true, which I don't see why it wouldn't based off of what I read in the paper and the results. So the paper is titled Intriguing Properties of Quantization at Scale. Not the best title, but the first thing I'll highlight is that, because I do it the opposite way all the time, this is released by a company called Cohere, and then Cohere's an AI company. They deal specifically with like AI and deep learning and large language models very specifically, so that makes a lot of sense here. And so the bottom line is with the introduction and what they break down is that and it's a known issue, and so that's why I think that this paper is significant within this. There's been a debate about an issue within LLM models with regards towards quantization. And so quantization is essentially taking a very large large language model, let's say like 50 billion parameters plus, and then essentially reducing the integers within and the bits to 8 bits, or we can go down to 4 bits, and then so that can reduce the size of the overall number of parameters. So, like for example, with the alpaca models and the llama models and Vicuna, you see 7 billion parameter and 13 billion parameter models, and those are all possible because of quantization, because they can take the larger model and essentially shrink it down. And within that, though, by doing that, there is performance degradation. And then so the question has been, are you always going to have that 100%, are you always 100% of the time going to have performance degradation when you do that? And then there's been people on both sides of that argument, and it's called emergent properties. And then so the debate has been, are emergent properties, when this quantization happens, are they nature or nurture? Is it 100% part of the quantization process? Does it have to happen, or are there ways around it? And what this paper shows is that it's nurture, not nature, that there are ways around it. And the significant breakthrough within this paper is they achieve a quantization process with virtually no drop-off in performance. So if you read through you start through and go through their background and their methodology. Their methodology is pretty straightforward. They take their own LLM model and they train it up, and then they go through a few different training steps, and they mention it. So that they go to they test at 410 million parameters, and then if things look good from there, then they'll scale it up to 6 billion, and then to 13 billion, and then to 52 billion is the max that they went, and then they would quantize the 52 billion parameter models down, and then see what the results would be. And then essentially within this, they give kind of just essentially the setup for exactly how they trained the models, which is extremely important, and to mention that so within their method, within the conclusion that they draw within this paper, their conclusion is that the reason why degradation happens within a quantization process is due to training, and the essentially their argument is that you can, if you know that you're going to quantize a large language model beforehand, if you train it in advance with that knowledge in mind, and specifically train it in certain ways with the quantization process in mind at the end, that's what will eliminate the degradation seen. And then the kind of like bottom line conclusion that they draw is that when they go through the benchmarks here, that they have essentially a 0.16% drop-off rate via quantization is what they're able to achieve. And this is huge, because there's been I've seen a lot of papers recently that have come out and claiming that it's more likely that the opposite is true, that the emergent properties and the degradation that occurs emergently within quantization is inherent within it. And a lot of papers are oh, we shouldn't be looking towards quantization as the answer. We need to look in other areas because of the performance degradation issues, and because these performance degradation issues are inherent within quantization. And so what this paper is showing is that it's not, that we we can 100% work around it. They have their proof. They've built out their own models. And then they also lay out an interesting argument here, which is what they, just going back to the top, which is essentially their hypothesis and how they came up with this, it is that essentially they looked at different LLM models and then noticed that some had degradation issues more significantly than others. So for example, there's one model called the Lambda model, which is like based off of like Lambda, and it's 47% drop off in quantization. So not the Lambda model specifically, sorry, but there's a model that has huge 47% drop off, and then the other one that they use is Bloom, which is, they show that Bloom is a lot more stable and has less drop off within it. So and here, yeah, it's talking about it essentially right where we're looking at right here. And I think that they don't actually name the model that has the 47% drop off, but I did notice that 47% drop off in a model is kind of insane for quantization. So you can see how it has been a problem, and then how there have been like a lot of arguments around whether or not that that drop off, that emergent drop off with quantization process is inherent. And with this, it's not. And then so the conclusion that they draw, and the interesting question that I draw as well from this, is that so if this part of the emergent process of quantization isn't nature, then there's other parts of this process that people are still working through, and it's most likely then that they aren't nature as well. So for example, AI dementia, which is essentially when you're training generational models across generations of data, the later generations have kind of like a drop off in performance and learning abilities, and then so they term it AI dementia, and then what the hypothesis and what this paper is showing is that things like that are solvable, and that's been a question that we have is can we actually solve for those things? And it looks like the answer is yes, we can solve for AI dementia, we can solve for emergent properties within quantization, and to me this paper is fantastic news for the AI community overall, and I just wanted to get this out because this is a huge breakthrough, and I think once people actually read this paper and take a look at exactly what it says, it's a cool way forward. So thanks everybody. If you like this kind of content, please like and subscribe. Thank you.